what we discussed the last day. Can you see my screen?
Yes, sir.
Yes, sir.
You can see my screen. Okay. And now see, uh, a brief recapitulation of what we did the last day. A truss is basically a pin-jointed structure where the defined members only carry axial forces and no shear force. Any member in a truss may be subjected to tension or in compression, but it cannot take any shear, bending, or torsion. Now, when you get a two-dimensional truss, three-dimensional trusses are also there that can be solved only by computer approach, computer analysis, because the number of equations involved are large. And in three-dimensional truss, at any joint, you get three equations of equilibrium. In a plane truss, at any particular joint, you get two equations of equilibrium. But when you consider the structure as a whole, you get three equations of equilibrium: summation fx0, summation fy0, and summation moment 0. But when you come to a particular joint, then the equation summation of moment is 0. That becomes redundant, that becomes useless, because all the forces which pass through a joint are concurrent forces, and therefore the chance of developing any couple or moment is not there. Now, when you really go to analyze a truss, first you have to see that whether it will be possible for you to solve the truss. Therefore, you want to initially get the support reactions. Now, support reactions, you know that if you have a roller, then you have only one support reaction which will be perpendicular to the plane of the roller. And if you have a hinge support, then you will be having two reactions. Now, the number of reactions in the two supports, if that is equal to 3, then the structure can be solved by the equations of statics, summation fx0, summation fy0, and summation m0. That is the mathematical implication, but it has got a physical implication as well. A structure which is solvable by the rules of statics, which is known as a statically determinate structure, is stable, no doubt, but it is a very sensitive and vulnerable structure, which means that if any one of the support reactions is withdrawn, then the structure will become unstable. And therefore, real life structures are normally made indeterminate. Now, what is meant by degree of indeterminacy? Degree of indeterminacy is nothing but the difference between the number of unknowns and the number of equations available. For example, if you have a truss where you have two supports, both are hinged, then the total number of reactions, 2 at each joint, is equal to 4. But you have three equations of equilibrium, and therefore number of unknowns minus number of equations, that means 4 minus 3, 1. This is the degree of external indeterminacy. Now, to get that total number of unknowns in the truss, what you have to do is you have to count the total number of members and count the total number of reactions, because the member forces are also unknown. So if the number of reactions is denoted by R and the number of members is denoted by M, then M plus R is basically the number of unknowns. And if you have J number of joints, then you have 2J number of equations. So M plus R is the total number of unknowns, 2J is the total number of equations, and therefore M plus R minus 2J, that is the degree of total indeterminacy, overall indeterminacy. Now, if you subtract external indeterminacy from overall indeterminacy, then you will get internal indeterminacy. Now, this internal indeterminacy has got a significance again. If a structure is internally determinate, then it means that it is provided with the minimum number of members required for its inner stability. Means if any one member fails, the structure will become a mechanism. Internal instability is called a mechanism. Now, you can this question may peep up in your mind that uh, uh, if the number of joints is j, the overall number of equations is 2j. So, sir, is there not any moment equation? Are we not getting any moment equation? The answer is no. If you take certain moment equations by taking equilibrium of the forces about any joint, those particular equations are not independent equations. Do you understand? So if a particular truss has got 10 joints, then you cannot get 10 into 2 means 20. You cannot get more than 20 independent equations. Of course, some of these equations may be force equations, some of these equations may be moment equations, but the number of independent equations cannot exceed 20. So this is the story. Now, the trusses can be solved either by method of joints or by method of sections or by combination of both. And if the problem size is very big, then we solve it by softwares which utilizes matrix approach of structural analysis, which you will be exposed to in the higher classes. Now, we talked about method of joints the other day. We also mentioned that when a particular bar force has not been solved, even if you know the nature of the force, by default you assume that as tensile, you assume that to be acting away from the joint, and to solve it, if you get it negative, then of course you conclude that it is a compressive force. And at any particular joint, two unknowns are solvable at a time. So you have to choose your solution path in such a way that the entire truss can be solved. And the last day, we also discussed about a problem in this book, and I told that you can, you can uh, solve the problem by yourself and compare the results with the book. Have you done it? Have you done it, my students? The problem which we were discussing, I shared this book with you.
Yes, sir.
So you have solved the truss by yourself, and have you compared the results which are
Yes,
given in
sir.
the
Yes,
book?
I have.
They are matching, no?
Yes, sir.
Excellent, excellent. Now we can go to the method of sections, of course. Uh, we will go to the method of sections, which is very interesting and very simple also. I am showing you the method of sections from Subramaniam's book. I will share this book with you, don't worry. It is very easy actually. Method of section is a very easy approach. I will explain how it works. And in reality, we go for a combined approaches. I mean, we solve the vertical support reactions by the method of joints, and then method of sections we apply. And in method of joints, you have to come from one end. But if I ask you to get the force in any intermediate member, then in method of sections, you may not come on by sequential solving of all the members from one support. You can just solve any intermediate member. I will show you. Method of sections you know, and therefore you know that you have to come from one joint like that. Now see, if this is a particular truss, I will explain you and then I will discuss a numerical problem as well. See, if you want to get member forces in CE, DE and DF, then the section X has been passed, which is cutting all the three members. Now, when you pass a section, you have to ensure that you have to cut, you cannot cut more than three members. You cannot cut more than three members because that will not be of any use. If you cut three members and you take equilibrium of one side of the truss, then you will be getting three forces, because once a member is cut, the internal force comes out as external force. And since these forces are non-concurrent, you have three equations of equilibrium: summation fx0, summation fy0, and summation m0. And therefore, if you cut more than three members, you cannot solve them all. Have you understood? In a particular joint, you have to choose a joint in such a way that two forces are unknown. You cannot solve more than two forces at a particular joint, and therefore you have to plan your solution sequence so that you go joint by joint and thereby solving two unknowns at each joint. In method of joints, method of sections as well, you have to take sections, but you have to keep in mind that the section should not cut more than three members, because in method of section, in a single go, you cannot solve more than three unknowns, because in case of non-concurrent coplanar forces, you get three equations of equilibrium: summation fx0, summation fy0, and summation m0. Is it clear to you? Now, see, this is the concept. It will be better understood if we go to a particular problem. Uh, let's do that.
Sir, can you repeat why section cannot should not be cutted more than three lines?
Because if you cut more than three members, then you cannot solve them. Because I'm showing you, because for non-concurrent coplanar forces, you can solve only three unknowns at a time. Figure 13.31a, just 13.31a is here, 31a, but where are the forces? Okay, there are the forces. Yeah, here you have a 9 kilonewton force, here you have 12 kilonewton force, here 12, here 18, and here 18. Now see, initially this is a hinge and this is a roller. Therefore, you have three unknowns. And if you consider the truss as a whole, then there are three equations of equilibrium. So it is externally determinate. And if you basically count the number of members, please count the number of members. Have you counted the number of members?
25.
Yes.
25.
Ah,
25.
25. Ah,
Yes, sir.
Yes, sir.
fine. 25. So 25 is M, number of members. What is the number of reactions?
3.
Yes, 3. So 25 plus 3 is 28.
28.
How many joints are there?
Truncated roller joint.
Yes. How many joints do you have?
14.
7, 1, 2, 3, 4, 5, 6. Yeah, 14. So how many equations can you have?
28 as well.
Yeah. So 28 equations you can have. 28 unknowns you are having. So the structure is determinate both externally and internally. Okay. Because externally it is determinate. Because externally you can have three equations and you have three unknowns. Okay. So it is solvable. Now I would like to make one point. See, in this particular case, since all the loads are vertical, so the reactions at A and N both are vertical. The reactions are not, there is no horizontal reaction. But when you actually calculate the determinacy or indeterminacy of a particular structure, please do not consider how the load is applied. This load is vertical, so the reaction is vertical. So never you think that number of reactions is 2. The number of reactions is 3. Because when you consider, whenever you check determinacy or indeterminacy of a structure, you have to think about generalized loading. Is it clear?
Yes, sir.
Okay. Because if you take only vertical loads and vertical reactions, the number of reactions become 2. I agree. But when you consider overall equations of equilibrium, summation H equal to 0, that equation again becomes meaningless. So ultimately equations become also 2. So you should always say that it is, you have to consider all the performance of the structure against generalized loading. I will give you another example. If you have a beam where both the supports are roller supports. So if and it is subjected to only vertical force. So equilibrium be established? You tell me. Both the supports are roller supports, which can provide vertical reactions,
No,
and the
sir.
and if
Horizontal reaction will not be there.
I understand, but if you talk in terms of the load only, if you have vertical load only and you have rollers which can give vertical reactions, then is equilibrium possible or not?
Yes, sir, possible.
It is possible, but still the structure is unstable. Because as one of your friends had said, as I have told, that this particular structure is not stable for under generalized loading. Maybe under a particular type of loading it is stable, but it is not stable under generalized loading, and therefore the structure is unstable. Do you understand? Anyway, so let us start this particular problem. We will having a number of things to learn here. Initially, see, in method of sections, if you want to solve all the members, uh, you can use the method of sections. You can, if you are asked to choose find the force in any particular member, you can use the method of sections. But for the joints which are adjacent to the support, which are connected to the support, there you have to apply the method of joints. You come here, if you want to get the bar force in member AB and AC, then you tell me what you have to do. Tell me.
Can you please repeat once again?
Yes, I will definitely repeat. My point is that you can apply the method of sections to get the bar force in any intermediate member anywhere within the structure. But when you want to get the bar force of the members which are connected to the support, you have to apply the method of joints. Okay. You come to you
Okay,
come
sir. Okay.
Yeah, you come to support A. Then you have an upward force 30.5. Now you have a horizontal force FAC, which will be acting towards the right, because I have told you that by default you will assume that the forces are tensile, and you'll be having a bar force in AB which will be acting from A to B. Am I correct?
Yes, sir.
Okay, fine. So if you take summation V equal to 0, then you get an equation 30.5 plus FAB equal to 0. So FAB is minus 30.5, which means it is compression and it will be acting towards the joint A. Am I correct? Am I correct?
Yes, sir. Yes.
Okay. But what will be the bar force in member AC? Tell me. Member AC will try to generate a horizontal force. But is there any horizontal load there apart from FAB AC? At this particular,
No, sir.
no, sir.
No, no.
And therefore, if AC, if it is non-zero, then there is no other force which can equilibrate the force AC, and therefore AC must have a force equal to 0 and is called a zero force member. Is it clear to you?
But sir, the horizontal component of FBC is there.
Original component of,
The force on BC member will be acted on the AC.
The reaction at A, I think.
I
Left
understand,
side.
I understand, but for a particular member, you cannot get two defined forces from two defined joints. Huh? So if you look at joint A,
Yes,
if
sir. With respect to joint A, it is zero.
0, and therefore it will be 0. Okay. Are you all convinced?
Yes, sir.
Okay. Now see, I'm just putting on hold this discussion and coming to identification of zero force members. You come here. Come here. You should always trying to think about the equilibrium joint wise, and you will understand which one is zero force member and not. You tell me, if you talk of these two members, AB and AE, there is no load there. Are they zero force member or not? Are they zero force members or not? You tell me.
Yes, sir, 0.7.
Yeah, they are zero force member, because if you consider the equilibrium of joint A, you can draw FAB, you can draw FAE, but FAB will having a vertical component. Okay, is there any
Yes, sir.
is there any vertical force there?
No, sir, no, sir, no load.
So nobody can equilibrate the vertical component of AB, and therefore FAB has to be zero. Now, if AB is zero, then AB cannot have a horizontal component as well. But the bar AE is horizontal, so the bar force there will be horizontal. So who will equilibrate? The force in member AE. So AE shall also be a zero force member. Are you convinced?
Yes, sir.
Yes, please.
Yes, sir, yes, sir.
Okay. Now you come to joint C. What is your observation about bar force BC and bar force CD?
Both are zero force members.
দুটো zero force তো?
Yes, sir.
Okay, okay. You come to joint E. Member AE is a zero force member, so it is not there. Do you understand what I say? Once you have concluded that one member is a zero force member, then it is not there. Are you agreeable to me?
Yes, sir.
Okay, so it's not there.
Yes, sir.
So now you tell me that in among member EB and ED, is there any zero force member?
ইটা কি রোলার জয়েন্ট স্যার?
এটা roller joint, হ্যাঁ।
তাহলে ইডিটা জিরো ফোর্স মেম্বার।
ED is zero force member. You are correct. ED is zero force member because no horizontal force is there to equilibrate it. What about EB?
ইবি হ্যাজ দ্য রিঅ্যাকশন।
Sir, EB, E তে একটা torque will be, I think.
না, there is a reaction at
Reaction.
E. The
Yeah, right.
particle reaction that should be balanced.
Yes, you get a horizontal force at E, and therefore EB is not zero force member. Okay. Now BC and CD are zero force members, and therefore they are not there. Now member ED is a zero force member, so it is not there. Now you tell me, what about force in member BD? Will it be zero force or force will be there?
No, sir. The P load should be balanced by that.
Yeah, P load should be balanced by the component of FBD. Exactly so. And moreover, since D is a hinge joint, you have two reactions, and therefore the member BD cannot be zero force member. Okay. Come here. Come here. You tell me that what will be, can you identify zero force member here? Is there a zero force member?
CD.
CD is a zero force member. What is the logic?
Sir, FD.
FD is zero force member. What is your logic?
There is, if a force is applied along FD, so how can the beam C balance that?
This is 90 degrees, so it cannot be balanced, no?
Yes, sir.
Okay. So if D is zero force member, I agree with you. So FD is zero force member means FD is not there. FD is not there.
Then CF will be zero force member.
Why?
If similarly, if FD is not there, if CF applies a force on GE member, so that cannot be stable.
Why not? Your answer is incorrect. I mean, your answer is correct but incomplete. Your logic is not correct. Why? Because the CF is not at right angles with G. So CF should have a component along G, and the bar force along G will counteract that.
Yes, sir.
Your answer is correct, but your logic is wrong. If CF is really a zero force member, but establish why?
Sir, if vertical force, vertical component cannot be balanced.
Exactly, that is the answer. That is the answer because GF and FE, they are in the same line, and therefore all the forces should be in the horizontal direction. And therefore, if CF has a force, it has to have a vertical component. That vertical component cannot be contracted, and therefore FCF is a zero force member. You are absolutely correct. Okay. Now, what about member BG?
Not a zero force member because
Very
it
good. Very good.
stabilizes the force
Yeah, yeah,
E.
yeah. Yes, yes. Come here. Tell me the zero force members.
Sir,
BH,
CD and ED.
Correct. CT and ED are zero force members, so they are not there.
BH,
Huh?
BH, sir.
BH is zero force. Why?
Uh,
Sorry,
if
you just
BH
spoken,
is
sir.
perpendicular, if BH applies the force,
Had
then
it
AF
had it
cannot withstand.
okay? Had it not been perpendicular, then if the angle was 70 degree, then BH would
Then
have
also the vertical component
not vertical
exists.
component, the force perpendicular to H. Say like that, not
Yes,
vertical.
yes, yes.
You are absolutely right. So in a nutshell, if two members are in the same line, then the third member should be a zero force if there is no nodal load. Na vertical
Yes.
horizontal, that is not the point. If two members are in the same line, then they cannot offer a reaction in perpendicular direction of the length of the members, and therefore any other member which meets that member, that has to be a zero force member. Or in other words, you come to your high secondary days, if three members form an equilibrium or four members, whatever, then a closed polygon can has to be formed. Na? So
Yes.
if you have three arrows where two arrows are in the same line, can you form a closed triangle? No, you
No,
can't.
sir.
No, you can't. But if in H, if you have a particular force, then AH and FH, those are in same line. I agree. But then if HD and the force, they can assume reasonable magnitudes to form a vector quadrilateral. Although two lines are the same line.
Sir, is the joint G a roller joint?
Let me see. Yeah, it's roller.
Then, sir, AG will also be a zero force member. Like G has only a horizontal component, no vertical.
Excellent. Very good. Member AG is also a zero force member. So I hope that your concept about zero force members is okay. Take it. It's okay. It's good.
স্যার তাহলে কি চারটে হলো?
পুরোটা অব্দি আর দেখলাম দাঁড়াও সিটি জিরো ইটি জিরো লেখো এটা জিরো সি কি জিরো
No, sir.
গুড
P আছে মানে
আচ্ছা বিএইচ জিরো লেখো 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 তোমরা বিএইচ জিরো এএইচ জিরো তাই তো বিএইচ জিরো এইচ জিরো আর ডু এগ্রি সরি বিএইচ অ্যান্ড এজি হ্যালো
Yes, sir. Yes, sir. AG.
আচ্ছা তুমি একটা কথা বলো তো ইন ই হ্যাড দেয়ার বিন নো ফোর্স দেন সি উড হ্যাভ বিন
Zero force member.
right so if c would have been zero then c is not there
Yes.
in that case fc.
Also zero force member.
Yes. These are the things which are given in GATE exam. Okay. এবার দেখবে once a particular member is zero force, you just think that it is not there. Then you again rethink. Just wait for a minute. So coming back to method of sections, so you know the reactions if AC has to be 0. Now if you want to get bar force in DF, FE and EG, you can pass a section X. It has cut 3 members. Now please pay attention. So when you have cut the section, the this particular structure gets divided into 2 parts, and therefore the internal bar forces come out as external forces. So the member force DF is designated by F1, the member force EF is designated as F2, and the member force EG is designated as F3, and all of them has been assumed to be tensile, and therefore they are all acting away from the away from the portion whose equilibrium I am taking. Is it clear to you? Bolo.
Yes, sir.
I have cut it into 2 parts. I am taking equilibrium of the left hand side, and therefore I have all the initially I have assumed all the bar forces to be tensile, and before that I had found out the support reactions. If I take moment about n, then I will get Ra. If I take moment about A, then I will get Rn, or if I take summation V equal to 0, then I can get Rn as well. Rnv AV means vertical. Now come here, look here, see these members. You tell me which member you want to solve at the beginning. You tell me DF, FE, FG, EG. You name any one member.
DF.
You want to solve DF. Okay. So
Sir,
where
sir,
bolo.
EG would be easier, like if we consider the torque at F.
We all will be easy. I will telling you. Everything
Sir,
will be easy. If somebody wants to solve member force DF, then the other two members means EF and EG, they are meeting at E.
Yes, a moment will be calculated on M of E.
Yeah, you take moment about E. If you take moment about E, then you get 30.5 into this distance, means 6 meter clockwise, minus 9 into 3, that will be anti-clockwise, plus F1 into 2, that will be again clockwise, that will be 0. Since F2 and F3, they all pass through E, and the bar force and the load 12 also passes through E, so they will not have any contribution in moment about E. Is it clear to you?
yes, sir.
So 30.5 into 6 minus 9 into 3 plus F1 into 2, that will be 0. So F1 gets solved. Now, if you want to get the member force EG, as one of your friends was telling, the other two members meet at, tell me, if you want
F.
to get, yeah, F.
Yes.
F1 and F2, they meet at F.
The
So you take,
summation of f of x equals to 0. Total x direction force will be 0. So I have calculated one. So the another can be.
yes, yes, of course. That is also a good approach, because all the forces are vertical. So this particular force and this particular force, these two are horizontal. So they must compensate one another. You are absolutely correct. You are absolutely correct. But see, had there been any generalized load here, okay. So I'm telling you a generalized approach. Whenever you see that you are wanting to solve a particular member, see where the other two members meet. If you want to solve F1, you see whether F2 and F3 meet. If you want to solve F3, you see where F1 and F2 meet. Although the approach that you have told is that is equally correct. And if you want to solve F2, then what will you do? Tell me.
30.5 minus 9 will be the answer. Just.
We will have force
The 12 there. Summation of Fy equals to 0.
Exactly, very good. Summation of F5 equals 0, because F1 and F3 both are parallel, they never meet, but doesn't matter, they are horizontal. So if I take vertical forces 0, then F1 and F3 cannot contribute, and therefore F2 gets solved automatically. Is it clear? Is it clear to you?
Yes, sir.
Okay. So this is the method of sections. There are many other problems you should solve, and you will compare the results with the book. that you have to do, but the principle is same. The principle is same, don't worry. Now, sorry. In compound trusses, actually simple trusses are inserted within another truss. That is actually a compound truss. See, this triangle can be a truss that has been inscribed within this triangle. So a compound truss is nothing but it is made up of a number of simple trusses. This is one truss, this is one truss. They have been connected by this member, maintaining the triangle configuration. And other triangular trusses are inserted within this. So these are determinate trusses, but you may face a difficulty in by applying only the method of joints. You come here in method of joints, how many unknowns can you solve at a particular joint? In the method of joints, how many unknowns can you solve? Hello?
Sir, 2.
Yeah, two. So if you come to joint A, then which members can you solve?
AI and A.
Very good.
AI is at the vertical
Very
forces
good.
can be
A and AB. A and AB. Then which joint you want to go to? If you go to joint B, then you see there are three unknowns. BA is known, but BI, BJ, BC are unknown. Am I correct?
Yes, sir.
Okay, if you come to joint I, IA is known, but IB, IJ, IH are unknown.
So as the structure is symmetrical, the BJ and BI will be same.
BJ and BI, no, they won't be same. BI and BJ won't be same. BJ and KD will be same. BI and DF will be same. The structure is overall symmetric. Okay. IB and BI and JB won't be same. Uh, are you convinced?
Yes, sir.
Yes, sir.
Okay. But if you take a section AA as it has been shown, it's AA or yeah, it's AA. Then you see three members have been cut. Okay. Have you understood? So once three members have are you seeing the section?
Yes,
Hello?
sir.
Okay.
Yes, sir.
So it has cut members HG, JC and BC. So JC and BC are passing through C. So if you take equilibrium of the left hand side portion and take moments about C, then FHG becomes known. Am I correct? Am I correct, my students?
Sir, I will repeat.
Yeah,
Please
sure.
repeat, sir.
Surely I will repeat. You tell me. I have seen that in method of joints, I have applied the method of joints at the support joint. At method in the method of joints at any particular joint, two unknowns can be solved, and therefore I found that I cannot proceed. I cannot proceed. So, so I have taken a section, as I was telling a few minutes back, that when I personally solve a truss, I go by a combined application of both method of joints and method of sections. So if you solve, if you take a section AA, then you are cutting three members. I told you that don't cut more than three members. Have I said that?
Yes, sir.
So you cut three members. So the members are, if you take, see, equilibrium of the left portion you can take, equilibrium of the right hand side you can take. That's up to you. If you take equilibrium of the left hand portion, then forces are HG from H to G, because tensile force you have to take. Forces will be JC from J to C, and force will be BC from B to C. Fine. Now, if you take moment about C, then force JC and BC both pass through C. So, member force HG becomes known. Is it correct?
Yes, sir.
বুঝতে পারছো বাবা? তোমরা বুঝতে পারছো? তুমি যদি এখানে মোমেন্টটা নাও, you take moment here, then this force will vanish. This force will only be there. If you take moment about H, if you take moment about H, then this bar force and JC bar force, they all pass through H. So bar force BC will come out. And if you take summation of V equal to 0, this member is horizontal, this member is horizontal, but JC has got a vertical component. So JC becomes solved. তোমরা বুঝেছো না বোঝনি?
Yes, sir. Yes.
বুঝেছো?
Yes, sir.
ওকে, তোমরা একটু সলভ করবে বাবা, হ্যাঁ সলভ করে দেখবে কিন্তু। Please solve it by yourself. আমি প্রিন্সিপালটা বললাম। So once these three members are known, then I don't have any issue. Just hold on. Just hold on. So once Hg is known, can you hear me? If you come to if you come to joint H, then you tell me, can you solve Hg and Hi? Because there are only two unknowns. বুঝতে পেরেছো?
Yes.
This member is known, so this and this I can solve. And in so what to do? Tell me. Yeah, you come to joint B. BA was pre-known to me. BC is known by method of sections. So can I get BI and BJ?
Yes, sir.
Right. So you have to do it by your own hand. তোমার করতে হবে, বুঝলে না করলে, if you don't do it, then you will not understand it. So this is compound truss. You solve it. And there is another type of truss which is called a complex truss. That is again determined. This is overlapping members. This is not, there is no node over here. You, you count the number of reactions. How many?
3, sir.
3.
So it's externally determinate. So count the number of members.
Sir, 9.
Yeah, 9. So number of unknowns.
Sir, 18.
No, number of members 9. Number of reactions 3. So 12.
Yes, sir. Yes, sir.
How many joints?
6.
6.
This is not a joint. So yeah. So how many equations?
12.
So determinate. Okay.
Yes, sir.
You can get the reactions. You take moment here. You get the vertical reaction. You make summation vertical forces 0. You get the vertical reaction here. You make summation Fa is 0. You get the horizontal forces here. So external bar force, external reactions are known. Now how will you start solving the member forces? বলো কিভাবে করবে? পারবে? See,
Sir, we have to do a cross section because even at joint A there are 3 members.
try to pass a section. Try to pass a section which will cut 3 members.
Sir, AF, AD আর AB কে কেটে একটা সেকশন দাও।
কোনটা?
AF,
হ্যাঁ
AD আর AB।
হ্যাঁ, করে সেকশন তো লাভ হবে না, দুটো তো একই জায়গায় দিয়ে যাচ্ছে, মানে মেথড জয়েন্টসই হয়ে গেল। 3টে মেম্বার তো একই জয়েন্ট দিয়ে পাস করে।
Yes, sir. Yes.
তাহলে পারছো না তো, মানে কেউ, আমিও পারছি না। So what you do, you have to see, very interesting. You have to, this is known as Henneberg's bar replacement method. Henneberg, Henneberg, Henneberg was a person. What he said, that you just lift one member, one particular member, you just cut it. This member AD, we have cut it. We have cut it. But we have introduced another member EH here. EC here. So EC member is not there, I know. And in ED, there is a force, I know. So let the force in ED be X, which they have told, they have given as 1. I will tell that you take it as X. I tell you why they have given 1. So the structure is subjected to a load P and a bar force in AD. Bar force in AD, let that be X. Then you can solve the truss because this X is known to you algebraically. You solve the truss and you get a bar force in EC in terms of X and P. But in reality, EC is not there. So equate that to 0. X is solved. Do I repeat?
Yes, sir. Please repeat.
Yes, sir.
Acha, we know that to maintain the stability of a truss, all the members should be a part of a basic triangle. Taito? All the members should be parts of basic triangle. So if I withdraw the member AD, I'm not withdrawing really. I'm assuming that the bar force in member AD is X. They have given as 1. I do not know why. They have given 1. Anyway, I don't do that. I give it X because they have solved it twice. Under P forces, they have solved it. They have given unity and they will solve it numerically and multiply everything by X. Because if this is 1, then they get the bar forces. So if this is X, multiply all the bar forces by X. So that is not a problem. For me, when I was a student, I used to just solve them by assuming this is X. But by withdrawing member AD and by inserting member EC, I am not destroying the basic triangle of any member. তুমি দেখো, যে কোনো একটা member is a part of a basic triangle. Okay. So this is a stability রয়েছে। তুমি দেখো, যখন এটা একটা ট্রায়াঙ্গেল হয়ে গেল, so these 3 joints are stable. যখন এটা ট্রায়াঙ্গেল হয়ে গেল, these 3 joints are stable. So this joint is stable, this joint is stable, this is a support joint. So these 2 members are also stable. Now, if you solve the bar forces in all the members, it's true that you will get in terms of P and you will get in terms of X. P is the applied load, so P may be numerically given. Now, whatever bar force you are getting in member EC, that is basically not there. Member EC is not there. So equate that bar force to 0. Then you can solve X. Now, once X is solved, you can get bar forces in all other members because all other member forces were in terms of P and X. Something is going wrong with this book. Have you understood? Hello?
Yes, sir.
Something is wrong with this book. It is not showing properly. Anyway, let us stop here for today.
This book you have given to us. Hitler.
আচ্ছা, পবিত্র
Yes, sir.
পবিত্র তুমি সেকশনের অ্যাটেন্ডেন্স নেবে and সৌভিক
Has a name.
আচ্ছা আচ্ছা আমি হিবলার I have given to you but Subramaniam I am not given না
No, sir.
No, sir.
I'm giving
ইবলাটটা দিয়েছেন স্যার
হ্যাঁ বলো বাবা
ইবলাটটা আপনি স্যার দিয়েছেন সুব্রমণিয়ামটা দেন
আমি এক্ষুনি দিয়ে দিচ্ছি ওকে
স্যার সুব্রমণিয়ামটাই কি রামানুথম?
না না স্টুডেন্ট আর মতো না, আমি মিটিংটা থেকে বেরোচ্ছি, আমি তোমাকে এখন দিয়ে দিচ্ছি এটা, কেমন?
স্যার স্যার একটা জিনিস জিজ্ঞেস করা আছে। আজকে আপনি ওই যে বইটা দিয়েছিলেন কত দূর অব্দি ওটায় পড়ালেন আজকে? পেজ নাম্বারটা একটু বলতে পারবেন?
না গো, এটা তো আবার শো করছে না গো। আমি মানে মোটমাট কথা মেথড জয়েন্টসটা পড়ালাম, আর তুমি কি
ওকে ঠিক আছে, তো সেটা রিভাইজ করে নেবো। কোনো এক্সাম্পল বা এক্সারসাইজ কোনটা করলে স্যার ভালো হবে একটু বলে
দেখো,
দিন।
আমি যখন ছাত্র ছিলাম আমি যেটা করতাম, আমি ওয়ার্কআউট গুলো নিজে করতাম।
হুম।
ওয়ার্কআউট গুলো নিজে করতাম, জাস্ট দেখতাম মিলছে কিনা। কারণ
ঠিক আছে।
অনেক বইতে হয় কি জানো তো, এক্সারসাইজের উত্তর ভুল থাকে। এবার ওয়ার্কআউটটা তুমি কনসেপ্ট আমি তোমাকে শিখিয়ে দিলাম, এবার ওয়ার্কআউটটা যদি তুমি নিজে করো, এবার তোমার যদি কোনো জায়গায় উত্তরটা না মেলে, তুমি বইয়ের সাথে মেলাতে পারো যে তোমার ভুল
হুম।
হয়েছে না ওদেরই ভুলে, বইতেও ভুল থাকে।
হুম, ঠিক আছে। ওকে
ঠিক আছে?
ওকে স্যার,
আচ্ছা,
থ্যাংক ইউ।
তাহলে আমি মিটিংটাতে বেরোচ্ছি, আবার নেক্সট স্যাটারডে দেখা হবে। তোমরা, আমি বইটা পাঠিয়ে দিচ্ছি।
থ্যাংক ইউ স্যার।
ওকে, থ্যাংক ইউ এভরিবডি, রাখছি।
Thank you, sir.
ওকে ওকে, বাই।
Thank you, sir.
And please go with the class. If you,
Thank you, sir.
yeah, if you go with the class, then you'll be able to understand everything. Okay, ক্লাসের সাথে চলো। Okay,
ইয়েস স্যার।
bye bye.